Structural formulas don't have dots. That's the difference. Structural formulas, Lewis structures, Lewis diagrams, it means the same thing. If there's Lewis, it means there are electrons. Okay? Okay, so what is the electronegativity difference between hydrogen and bromine? What's that? 0.7. What is the difference in electronegativity between H and F? 1.9. So how would you characterize those bonds? Yes. So HF is above 1.7, so it's got ionic characteristics. Is it ionic or is it covalent? HF. Is it ionic or is it covalent? It's greater than 1.7. Okay, show of hands, ionic. Show of hands, covalent. Show of hands, don't want to make a commitment. Okay. Hydrogen, metal or non-metal? Non-metal. So this is covalent. Okay? So this is covalent. It has ionic characteristics. It's extremely polar. So this is a very polar covalent bond. It's a very polar covalent bond. You've got to look at the atoms involved to know whether or not it's ionic or covalent. If you don't have a metal, it's not ionic. Now put in the bond dipole. Bond dipoles are the unequal sharing of electrons. How do you show the bond dipole? This was just before we left yesterday. This will donate an H+. Because that hydrogen hardly has that electron near it, it's easy to pop off and leaves the electron behind. That's why these are acids when you dissolve them in water. Or like that. Either way, the hydrogens do not stick out to the side like a scarecrow. Okay? Electron pairs, lone electron pairs, take up more space than bonding pairs. So they push the hydrogens down, they push the bonds down. Water is a bent molecule. So if you have anything that has two lone pairs, anything that has two lone pairs on it, the two bonding pairs will get pushed down. Okay? The molecule shape is really important to its function. So you need to start getting used to drawing water like this. Okay, structural formula. Just the bonds and the atoms. And of course, common name is water. IUPAC name. Dihydrogen. Oh, sorry. Yeah, they are. They just don't know it. Thank you. Dihydrogen monoxide. Thank you. So the shape of the molecule, together with the electronegativity difference between the two atoms, determines whether a molecule is polar or not. This is polar. Yeah.
Again, so you don't want to create water.
IUPAC name would be dihydrogen monoxide, yeah. We're going to call it water. But if I ask you for its name, it's dihydrogen monoxide. Okay. So the shape, along with electronegativity, determines whether a molecule is polar or not. If water, if we did it like this, what is the electronegativity difference between oxygen and hydrogen? Oxygen and hydrogen, what's the difference in electronegativity? 1.4. Which direction does it go? If I was going to put on dipoles as arrows, which way would it go? Pick the bond on the right, the OH on the right. Which way would it go? Would it go towards the H? Would it go towards the O? Towards the O. So then this one will go in that direction. Now, you haven't had much physics yet. We call these vectors. We call these vectors. And what happens with vectors is you add them up. So if I am 1.4 to the left, and I am 1.4 to the right, so if I am the hydrogen over here, I'm going to add, and I end up here, but then I've got the other arrow going that way, so I end up where I started. If you end up where you start, you've got no net dipole, you're non-polar. Water is an amazing substance. It dissolves more things than anything else because it's polar. So this is not the shape of water because it's a polar molecule. If you have this shape, you end up with a net dipole. You have a dipole going this direction and a dipole going that direction. When you add them together, they don't cancel each other out because they're going in the same direction. To add these two vectors, you transpose the second vector on top, so it's like a head to tail part. The top of the arrow is the head. The positive part is the tail. You add head to tail. Did I end up where I started? I ended up where the blue star is. No. So I have a net dipole. Because I have a net dipole, I'm polar. Okay? I'm going to do these with you again in a couple of days. This isn't your lesson on how to add vectors. Okay? I'll show you this again. But because these vectors go in the same direction, they add to each other, they don't cancel, you end up with a net dipole, you're polar. You're going to be able to not only draw for me structures, you're going to actually be able to tell me if a structure is polar or not. So that's coming. Then based on that, you're going to be able to tell me whether or not it's got a high boiling point and a low boiling point. You guys are going to know so much chemistry, it's scary. Okay. But you're not going to stay up till 2 o'clock in the morning to figure it out. Yeah, we got to fix that. That's insane. Think when you're tired.
It's a rough life.
It is, but we gotta fix something. Okay, carbon dioxide. I'm going to teach you how to draw Lewis structures, so just bear with me while we do this one. I'm just going to tell you how it goes. Carbon. How many bonds can carbon make? 4. There's only 2 atoms that it's attached to. So it has to make 2 bonds to each of them. There's your Lewis structure. Does anybody want me to do the other one with all the dots? Speak now, or else I'm not going to do it. Yes? No? Indifferent. Wow. Okay, so there we go. Can you see all the electrons at the back? Can you see the lone pairs? Or do I have to do it bigger? Tiny bit bigger. I don't think there's... Ugh. Yeah, I have to change the size of my pen. I don't think we meant to do that big, but that works. Woo! Wow, I'm making dots. Okay, so there we go. There's our beautiful Lewis structure. Okay. So those are the lone pairs of electrons. Now, structural formula, of course. Just shows the bonds. Just shows the bonds. Okay. And of course, this is called carbon dioxide. 1 carbon, 2 oxygens. Okay, could you please calculate for me what the electronegativity difference is for carbon and oxygen? 1. So does that mean the bond is non-polar or is it polar? Non-polar? Polar? You've got this on your sheet. Right there. It's polar. So we've got polar covalent bonds, people. Just like water had. Who's the most electronegative? Oxygen. So our bond dipoles go like that. So this has polar covalent bonds, but guess what? They cancel. So you can have polar covalent bonds, but be non-polar overall. Because they cancel. Okay, so you went 1 in this direction, and then you went 1 back, so you're back where you started. So your bonds, dipoles cancel out, so it's a non-polar molecule, but it has polar covalent bonds. And we'll do more of these. So, because it's linear, it's all on a straight line, right? These 3 atoms make a straight line. It's linear. The bond dipoles go in opposite directions. They cancel. Non-polar. So just like we did with the ionic ones, you have the atoms on the left, and you have the compound on the right. So if I just ask for the Lewis structure, you're going to do what's on the right of the arrow. If I say, show me how it forms, I want the whole thing. All right, 1 special kind of bond, and then we're done. Do it on the same sheet. Coordinate covalent bonds. So I've shown you covalent bonds where one electron from each atom come together, form a bond. So you've got two electrons in the bond, both are sharing. So this is different. In a coordinate covalent bond, one atom donates both electrons to the bond. So one atom donates both electrons to the bond. So it must have a lone pair. There's two in particular that you will know this year. One of them is the ammonium ion. So the ammonium ion contains a coordinate covalent bond, so does the hydronium ion. All right, ammonium. So ammonia NH3 will look like this. That's ammonia. It has a lone pair of electrons. It's willing to donate it to something that doesn't have electrons, like an H+ ion. It lost its electron. So this pair comes in, and then you have four bonds. You can't tell which one is the covalent one. Don't know which one is the coordinate covalent bond at all. But we have something that came in with a plus charge. The ammonia does not have a negative charge. So overall, it still has a plus charge. That's the Lewis structure for the ammonium ion. So the lone pair of electron donates to the hydrogen ion. That's the coordinate covalent bond. Okay? All right.